Guys, how's everything going? This is JSer, who is not good at algorithms. My interview will be what happened on the day after tomorrow, and this is a Sunday. I'm going to do a live contest, but before that, this is about a biweekly contest 14660. Make two arrays equal by reversing subarrays. It's easy. We're given two integer arrays equal to target. Two arrays of target and array. In one step, we could select any non-empty subarray of array and reverse it. We are allowed to make any numbers of steps. Return true if we can make array equal to target. So like for 1, 2, 3, 4, we have 2, 4, 1, 3. And then we could reverse 2, 4, 1, and it will become 1, 4, 2, 3, and then reverse 1, 2, 4, 3, 1, 2, 3, 4. Well, I think that because we are allowed to make any numbers of steps. So if we just use the most basic reversing of two elements, like remember we have bubble sort, right? We have the bubble sort. So for any array, we could actually use bubble sort to make it ascending or descending, right? Yeah. So we just keep swapping two. And swapping. Suppose we're going to make it ascending. Okay, so for this array, we could bubble sort to make it ascending, and we can think it reversely. It means if we can change it bubble sort array, we can also do the reverse swap to reverse the reversing, right, and make it restore the origin array. So for two array. Actually, if we sort them, if they are the same array, and actually, they could also be reversed back. It means if the array have the same count of same count of each numbers, they could be reversed. They could be like they are interchangeable. We should return true. So the problem falls to do they have the same elements? Like for this one, they might be duplicates. So I think it's clear that we could do the counting, right? So we count how many numbers occurs in each array. If they are the same, then they could be they should be interchangeable. Cool. So let's do that. Count. So the idea is we first count target. The input for number is 1000. We could create a 1000 array, but it's not that performant. I use a map. I loop through all of the target and count it. And yeah, this is done. Now we loop through the array to check if they have the same account. Right? Okay, oh, I need to count 1 and count 2. Wow, this is not that performant, maybe. And then finally, we check if the counts are the same. So 4. Let's try run the code. Yeah, I think we're good. We're good, and let's try to see the time and space. Time. We traverse through the array, and finally we traverse through the map. Obviously, it should be OM plus N, right? Space. We use two array, which the the element was most okay, target I. Maximum is from 1 and 2000, so I should say for the worst case we're using 2000. It is constant. I'm not sure whether we should treat that as constant, because no, the length is also, so it's not constant. So we should say its worst case is all of them are different numbers. So that would be worst case. It's still n plus n. Worst. Okay, could we improve it? I think for time we can. This is the best we can do. If we just try to, or we can just use sorting. I think that's not performant. Sort. Let's try to write the sort one. Okay. Let's just sort them ascending. Okay, if they are not the same length, we could return fast, right? After we sort, and we will check each of them if each of them are same. So while target 0, we just use for it. Yeah, this is simpler, but actually the time is different. We have to sort 2, right? Sort 2, so it should be lm log m plus n log n plus m. Oh, they have the same length, right? Let's suppose this n and n, which is min m n. We have to figure out this one, so let's just 2m log m plus n. So om log n. Space. The best thing is that we don't use extra space, so it's constant. Cool. You see that we trade space for the linear space to improve the time. Okay? Okay. That's all for this one. Hope it helps. See you next time. Bye-bye.